Dear students, this is our fifth lecture of heterocyclic chemistry. Today we will discuss about fusion nomenclature of fused heterocyclic compounds of such type of heterocyclic compounds. And basically today we will see how we have to choose the base component and attached component, which are the two basic requirements when we have to use this fusion nomenclature of these type of heterocyclic compounds, which are called fused heterocycles. So first let us quickly define what are fused heterocycles. Now these compounds, they are constructed by a combination of two or more cyclic structures. So two or more cyclic structures, or we can also say components, they join together to give you fused heterocycles. So these are such type of compounds, so in which you can see this is first cyclic compound, this is second cyclic compound, and these two, they have joined, combined together to give you a single compound. So this is called a fused heterocycle. Similarly, this in these two components, they have joined to give you a single compound, which is called fused heterocycles. And the cyclic structures, as you can say, they contain maximum number of non-cumulative double bonds. So those double bonds which are separated by a single bond, at least one single bond, these are called cumulative, non-cumulative bonds. So the cumulative bonds are C double bond C double bond C. Such type of structures is called cumulative. Here you can see all these structures, they have maximum non-cumulative bonds which are possible. And one thing also very important, you can see each structure unit has one bond common with other. So this is the most important requirement for a compound to be fused. You can see this bond is shared by these two heterocycles, in which this bond is shared by these two heterocyclic compounds. So the basic most common requirement is these two cyclic compounds, they should have at least one common bond between them. Now how to name them, that's what our today's discussion is, fusion, and the system is called fusion nomenclature of fused heterocycles. So the basic requirement for this nomenclature is that the fused heterocycle whose name we have to give, it is dissected, or we can say it is separated into its components, in which one component, we separate this fused heterocycle into separate components, two separate components. So one component we will call it a base component, and the second component is called a attached component. So there are rules by which we can dissect, or we can break this heterocyclic compound. Now suppose this, if we carefully see, then this structure can be splitted into this one benzene ring, and this double bond is shared by these two heterocycles. So both of them will have double bond NH, N, and here we have nitrogen. So this component, it can be breaked into these two components. So when these two will join, we will get a single component. Now out of these two, one is called base component and another is called a attached component. So there are rules by which we can find which is a base component and which is a attached component. Similarly, this can be dissected into two components, benzene plus this. So these are the two structures in which it can be dissected. So this is benzene and this is imidazole. This is benzene, this is thiazole. So the common name, these are the common names and which have been recognized by IUPAC. We have discussed in my previous lecture of trivial names. So this is imidazole, this is thiazole, and it is benzene. Now out of these two components, one is base and second is attached component. Now the base component is that component which is heterocyclic system. Now in these two rings, you can say this is a purely carbocyclic ring, benzene, because it does not contain any heteroatom. So the the ring with heteroatom, or we can say heterocyclic system, is imidazole. So in this compound, imidazole is the base component, and benzene we will take as a attached component, and its name will become benzoimidazole. Generally, the attached component is written as a prefix. So this benzene, its prefix is benzo. We will discuss the prefix is for attached components in our next slides. So first thing is to dissect this component into two components, attached component and a base component, and there are rules by which we can find which is a base component and which is a attached component. And attached component is written as a prefix. So similarly, here the attached component was benzene, so it is benzoimidazole. Similarly, here attached component is benzene, so its name will be benzothiazole. So that are the names for these. It is E names for these compounds, benzoimidazole, and it is benzothiazole. Now the system which is heterocyclic, that has to be the base components. Now next thing is the components which we have dissected. First we try to give them their recognized trivial names if possible. If such compound it has any trivial name, then we will give them, like it is benzene, it is imidazole, they have trivial names, so we give them their trivial names. And if any of these components has no recognized trivial name, then we find the name by Hantzsch Widman rule, which is called a systematic name. We have already discussed in my first lecture of nomenclature of heterocyclic compounds. So I have given the link in description section of that video, where you can learn how to find systematic names for a monocyclic heterocyclic compound. So first we have to see if there is any trivial name available. If that is not available, then we will try to find its systematic name. And now if there is a choice, now this is a very simple case where I have told you that choose that component as a base component which is heterocyclic. So sometimes what happens, both the rings are heterocyclic, then which component has to be chosen as base and which component has to be chosen as attached component. So there are some rules that I will be discussing now. So it says, if there is choice, the base component is determined by the order of preference. Now what is the order of preference, that we will be discussing in our coming slides. So how to choose a base component. Now let us see the first rule. The first rule says that generally nitrogen containing component is selected as the base component. So let us see example. It says that if we have a heterocyclic compound which has both the rings as heterocyclic system, then we give a preference to nitrogen. So the nitrogen containing component is chosen as a base component. Now this can be dissected into these two compounds, this N plus, as this double bond is shared by these two, so here you go, it is pyridine, its trivial name is available, pyridine, and it is thiophene. Now the rule says nitrogen containing component is selected as base. Now this pyridine will be base component and this thiophene will be attached component. So that is how you choose. The first rule says nitrogen containing components, they are selected as base component. Similarly this, now if you split this, then it can be splitted into this NH, this double bond is shared by both the rings, plus this furan, so this is pyrrole and this is furan. Then as the nitrogen containing component is this, so this is our base component. So pyrrole is taken as base component, whereas furan is taken as attached component. So the first rule is simple, nitrogen containing component should be chosen as base component. Now the second possibility will be that components with heteroatom other than nitrogen. Suppose if we contain a heterocyclic compound which does not contain nitrogen, so then it says that if nitrogen is absent, the heterocyclic ring or the ring with other heterocycle is selected as the base component. So it is the same rule as my first slide as I discussed. Now here this does not contain nitrogen, but this is a heterocyclic system. This is not a heterocyclic system. So what it says, choose heterocyclic system as the base component. You can also remember this rule as it is very simple. We have to choose the heterocyclic component as the base component. So remember this. So this is furan. So this will be our base component. This is benzene. This is our attached component. So if we does not have any nitrogen, the first rule says that choose that system which contains nitrogen as your base component. But if it does not contain nitrogen, the rule is very simple. Choose heterocycle as a base component. Now here it contains a heteroatom, so it was a heterocyclic system. It is a normal carbocyclic ring, so we choose this furan as the base component. Similarly here it can be splitted into, as you can see again, benzene. We will break from this bond which is common. This bond is common to both of these two. So here you go, here comes the thiophene. This is thiophene. Now as this is a heterocyclic system, so this is our base component. In this compound, thiophene is the base compound component and benzene is the attached component. So these are the rules. Now let us see what can be the next case. It says that if both the components contain heteroatoms other than nitrogen, it says we have two rings, both the rings contain heteroatom, but none the ring it contains nitrogen and heteroatoms are other than nitrogen, then what it says that the component which contains heteroatom having highest preference is selected as base component. This we have already done in our Hantzsch Widman system. This was the table by which we chose the heteroatom with higher preference. Generally the higher periodic table, higher group in the periodic table is given preference. First oxygen family, then nitrogen family, then carbon family, and then boron family. Now oxygen, sulfur, selenium, tellurium, so their prefix are oxathia. So first, now according to this table we have to give preference, we have to choose the base component with this preference. So let us understand by this example. Now this ring, we can break this ring into two components. Here you go, it is thiophene, as this ring is this bond is common between them, so it is shared by both the rings. If we split, then it will go to both the compounds. Now here you go, it becomes like this. So it is thiophene, it is furan. Now as you can see, oxygen appears first in this table, so it has higher preference. So this furan is chosen as your base component. This is your thiophene, it is your attached component. So what it does says that if we have heteroatoms other than nitrogen, then we have to choose. First preference is nitrogen. If nitrogen is not there and both the rings they contain heteroatoms, then we have to choose that ring with that heteroatom which appears first in this table. So this table is quite simple. First comes the oxygen family, oxygen, sulfur, selenium, tellurium, then nitrogen family, nitrogen, phosphorus, arsenic, antimony, bismuth, then your carbon family, a carbon, silicon, germanium, tin and lead. Now if one atom is oxygen, one is your arsenic, then we will give preference to oxygen. If one is oxygen, one is nitrogen, then we will give preference to nitrogen, because our first rule says that it is always advisable to choose that component as your base component which contains nitrogen. Now these rules we have to consider when the heteroatoms they are other than nitrogen. Now out of now you tell me arsenic and your sulfur, which will have a higher preference. Sulfur will have a higher preference because it belongs to oxygen family, it belongs to nitrogen family. So this rule is quite simple. So these dissection is the most important in this nomenclature. Other rest everything other is easy. The first aim, the crux of this nomenclature is to choose base component and attached component. Now let us learn the next possibility. Now it says that component with the greatest number of rings. So what it says, a component with as many rings as possible is selected as the base component. So this we will do for those systems which contain more than 2 rings. So bicyclic condensed systems or polycyclic systems with the recognized trivial names, they are chosen as base components. Now see, now we can bisect this into these two components. Either we can break this bond or we can break this bond. Now if we break, I will give it 1, give it 2. Now if I break this one bond, then it will be this. So plus this system, okay, now it is pyridazine, it is pyrazine, sorry, it is pyrazine. Now the rule says that a component with as many rings as possible, and it should have a trivial name. Now this two component system, it has a trivial name. What is it? It is quinoline. Quinoline. So that is why it is chosen as base component. So there is no need to break this in 3 separate cycles, because we had a trivial name for this system that was available. So its trivial name was quinoline, so that's why we break from here and we get two components. Now the rule is say the component with the greatest number of rings. This component contains 2 rings and its trivial name is also available, so that's why we have chosen this system as your base components. This why we have not chosen this, because it contains lesser number of rings. So that is what this rule is all about. Now next rule is, if we have rings of unequal size. Now this now we are considering all the different possibilities that may be possible. This possibility is that if a fused heterocyclic system contains a ring of unequal size, the ring size is different but the heteroatom is the same. Now you can see here it is a 5-membered ring, it is a 7-membered ring. If we have to break this can we can break this into one as thiophene, and the second as this bond is shared by both the groups, and we have to have two systems which have maximum number of non-cumulative double bonds. Now it is a 1 2 3 4 5 6 7-membered ring. So it is a 7-membered ring. Now I have just oriented this, so I have done its orientation. Now this rule says that ring of unequal size, if fused heterocycle system contains a ring of unequal size but the heteroatom is same, then the component with the largest size of the ring is selected as base component. Now it is a 5-membered ring, it is a 7-membered ring. So which is the largest ring? 7-membered ring is the largest ring, so we will choose this as a base component. So it is thiophene, its name is thiophene, its common name is not available. This name is using systematic Hantzsch Widman rule, we have already discussed. So thiophene, this is our base component. This thiophene, this is the attached component. So this rule says that if both the heteroatoms are same, then we have to choose that components which is larger in ring size as your base components. Now in this was a 7-membered ring and it was a 5-membered ring, it is a larger size ring than this, so this is our base component. Similarly here we can break this into something like this, okay, pyran plus thiophene. Now it is a 6-membered ring, it is a 5-membered ring. So I have not made it something clear. So here you go, and this, okay. Now this is pyran this is its trivial name, and this is your furan. Now you can see it is 6 membered, it is 5 membered. So which is our base component? The which is larger ring. So this is our base component. This pyran is the base component because it is a 6 membered ring and it is a 5 membered ring, and this rule says that we have to choose that ring which has larger size as the base component. Now what is the next rule? Now he says that rings of equal size is same but with a different number of heteroatoms. One ring has a lesser number of heteroatoms and another ring has a higher number of heteroatoms. Now you can say this compound contains two rings and both are 5 membered rings. So I can write its component as NH pyrrole plus this is sorry, here you go, this is your oxazole, this is pyrrole and this is oxazole. Now this rule says that if ring size is same but one ring contains the greater number of heteroatoms and another ring contains the lesser number of heteroatoms, then the ring with the greater number of heteroatoms of any kind, now we have not to be worried about the nature of the heteroatom, the ring with the greater number of heteroatoms is considered as a base component. Now here say it contains only one heteroatom, this contains two heteroatoms, so it contains more number of heteroatoms, so it is chosen as your base component. So this oxazole is base component, pyrrole is a attached component in this compound. This is rule is quite simple. If we have two rings of same size but they contain different number of heteroatoms, then we have to choose that ring as the base component which contains greater number of heteroatoms. Like in this example, this ring contains one heteroatom, it contains two heteroatoms, so we have chosen the ring with two heteroatoms as the base components because the number of heteroatom in this ring is more than this ring. Now next rule what it says that now rings of equal size with equal number of heteroatom, rings are also of equal size, you can see they are of equal size and they also contains a ring with the same number of heteroatoms, both contains two heteroatoms. If I break this into two components, now these two components they can be this NH, this is imidazole and this is nitrogen, oxygen, and this is your oxazole, this is oxazole and this is imidazole. Now what does this rules? Now we have two rings with the same size and with the same number of heteroatoms, 5 membered ring, 5 membered ring, two heteroatoms, two heteroatoms. Now he says that if both the components it contains a ring of same size with equal number of different heteroatoms, the component containing ring with the greater variety of heteroatoms, we have to choose that ring as a base component which contains a greater variety of heteroatom, means which have more types of heteroatoms. Now here we have only one type of heteroatom, only nitrogen. Here we have two types of heteroatoms, oxygen and nitrogen. So according to this rule, the ring with a greater variety of heteroatoms is considered as a base component when we have two rings of equal size and equal number of heteroatoms. Now this oxazole is base component in this fused heterocycle and this imidazole is attached component. Why? Because this contains two heteroatoms, two type of heteroatoms, it contains only one type nitrogen, it has oxygen and nitrogen, so we have to choose that ring as a base component which has greater variety of heteroatoms. Now the next rule, it says that if two heteroatoms of the same group are present, the component containing the ring with the heteroatom of higher preference is preferred as the base component. Now let us understand this by example. Now you can see if we break this, this can be dissected into two components. One is this 5-membered ring. Again also we have a 5-membered ring. Okay, so here is the double bond, here is the double bond. Now this is oxazole, this is thiazole. Now both are 5-membered rings, both contains two heteroatoms, 5-member two heteroatoms, and both contains two type of heteroatoms, oxygen, nitrogen, nitrogen, sulfur. Now this rule says that the component containing ring with heteroatom of higher preference is preferred as the base component. Now nitrogen is same, we have to compare oxygen and sulfur. So out of oxygen and sulfur, according to our previous table, oxygen has higher preference, oxygen has higher preference than sulfur. So that's why we choose this oxazole as the base component according to this rule. Now I once again repeat this rule: two rings of same size, same number of heteroatoms, and same variety of heteroatoms. So 5-membered ring, two heteroatoms, two type of heteroatoms. Then if in this case we have to choose that heteroatom as a base component which has higher preference, the heteroatom having higher preference, the ring with the heteroatom of higher preference is given, the is taken as the base component. So now nitrogen was same, we have to compare oxygen and sulfur. So out of oxygen and sulfur, oxygen has higher preference, so oxazole is the base component, thiazole is the attached component. Now let us see in this case. Now we had if we split this into two compounds, so what will these two compounds will be? Double bond Se, here we have double bond plus this sulfur, nitrogen, double bond, double bond. Now nitrogen, this is again same case, 5-membered, two type of heteroatoms. Now we have to compare selenium and sulfur has higher preference than selenium. So this thiazole, it is E, thiazole, it is base component in this case. So we have to choose according to what? According to the preference in the table. Now the next rule, it says that ring of same size, this rings of same size with the same number and same kind of heteroatoms, 6-membered rings, two type of two heteroatoms and both are nitrogen, ring of same size with the same number and same kind of heteroatom. Now according to the rule, the component containing ring with the heteroatoms which have the lowest locant number is preferred as a base component. If you give the locant number, so or we can say we have to choose that ring in which the heteroatoms they are closer. So here suppose numbering it is abrupt numbering, not accurate, so it will give 1 2, it will give 1 2 3 4. So here the locant position is less. So simple, in simple words you can say that those ring in which two heteroatoms they are closer, that will be selected as a base component, and this component is pyridazine. So this compound is pyridazine. So in this compound pyridazine is selected as a base component because in this these two heteroatoms they are, we can say, either closer to one another or some of their locants will be less than in this case, because here the locants, these two heteroatoms are far. So here suppose if we do numbering like this, here the locant position is 1 plus 4 5, here it is 1 plus 2 3, so 3 is less than 5. So we have to choose this, and this compound is pyridazine as your base component. So the base component is pyridazine. Similarly in this case we have two cases. This case this component is imidazole, and this component is pyrazole, imidazole and pyrazole. And you can see here two heteroatoms, they are closer, here they are far, so sum of locant will be less in this case, so this pyrazole will be taken as a base component. So this rule says if we have two rings of equal size with the same number of heteroatom and same type of heteroatoms, then we have to choose that ring as a base component in which the heteroatoms are closer, or if we have to talk technically it means the components containing ring with heteroatoms which have the lowest locant numbers is preferred as the base component. In this case it was pyridazine, and in this case it was pyrazole. So these were some rules by which we can select base components. So we have to follow these rules when we will do the numericals. Then we will see, or we will do the exercises, or we will give names to the different heteroatoms. Then we have to use these rules. Now let us learn. So these were that was all about your base components, how to select. We have done many cases and we have tell you the rules. So these rules are quite easy, they are not difficult, you just have to do little bit practice, and when you start practicing these compounds and applying these rules, then you will automatically learn. So the best strategy is first have your rules with you, then with these rules you start solving problems. When you solve a number of problems like 50-60, then you automatically start learning these rules. If you simply try to remember these rules and do not practice with these rules, then you will definitely forget in a while. Now the second component out of this base component is called the attached component, and as I said in my first slide, it is added as a prefix to the name of the base component. So the complete name of a fused heterocycle, it becomes a prefix. Prefix is of attached component plus the name of your base component, that gives you the complete name. So this attached component is given as a prefix to the name of the base components, and it is very easy to find the prefix. So the prefix designating an attached component, it says the prefix of attached component is found by changing terminal e of trivial or Hantzsch Widman name of the component into o. It says that simply write the, if trivial name is possible, write the trivial name. If trivial name is not possible, write Hantzsch Widman name, then replace last e of that name with o, that will be the prefix. So examples, and this o is not dropped when followed by vowel. So we will do this rule when we will do examples. Similarly, if attached component is pyrazine, so this rule says that drop last e and replace by o. Remove this e, replace by o. Pyrazino, its prefix will be pyrazino. Pyrazole, suppose if a base attached component is pyrazole, then its prefix will be, remove this a, replace by o, it will be pyrazolo. Thiazole, remove e, attach o, thiazolo. So that is how we find the prefixes, by replacing last e of a trivial name or a Hantzsch Widman name with o. But there are some a few exceptions for this. Pyridine, according to this rule, its prefix should be pyridino, but the accepted is pyrido. So these are some exceptions, so you have to remember this. The prefix for pyridine is pyrido. According to rule it should be pyridino, but it is pyrido. Quinoline, it is quino. According to rule it should be quinolino, but it is quino. So these are some exceptions. So isoquinoline, its prefix is isoquino. Furan, its prefix is furo. Thiophene, its prefix is thieno. Imidazole, its prefix is imidazo. So please remember these exceptions. Please keep these in mind while assigning names to fused heterocycle or assigning prefixes to the attached components. So these are few exceptions to this rule, general rule, which says replace last e with o, that will be your prefix. So that is attached component. So that was all for today. So I think it was a very interesting lecture. So today I just discussed with you how to find your base component and attached component while naming the fused heterocycles. So fused heterocycles, they are obtained by fusing more than one, generally two or more than two cyclic heterocyclic compounds. So we have to break that into two components. One will be attached, other will be base. So we learned some rules how to find the base component. So the remaining component, that will be attached component, and the name of this fused heterocycle will be your first prefix of attached component, then name of the base component, that will be the name. So that we will use now. We will use all this information when in my next lecture we will do examples related to this. Hey, there I will directly, by applying these rules, directly solve the numericals, or we can say we will directly solve the problems. We will name these fused heterocycle. So thank you very much for your kind attention, and please don't forget to subscribe and share my channel.